Okay, we'll be continuing on seeing more examples on esterification. Okay, so let's suppose we have something like this example wherein we have acid halide and on reaction with primary alcohol. So what will happen again? We are using pyridine's presence. Okay, so we'll get something like this as our ester, and HCl would be formed. Okay, and next what will happen is, as we are using pyridine's presence, what will happen is this HCl will react with pyridine to form something like this compound. Okay, so actually what actually just happened in this reaction is OAT minus just attacked on this carbon atom, and as a result this Cl minus got itself removed from the bond between the carbon atom, and also the H plus from the ETOH would getting itself removed. Okay, so as a result HCl will be formed, and this compound will join to form ester group. Okay, so why do we exactly use pyridine? Pyridine is used to neutralize the HCl formed in the reaction. Okay, uh, what if you don't use the pyridine? So if you can just see that there is a alcohol on the left hand side and HCl on the right hand side, this is obviously stronger acid than ETOH. If pyridine is not used, then it will revoke the reaction back into the original state. Okay, but that is the usage of pyridine, that we can actually use even as the HCl is produced in the product side, even then the reaction will go into the forward direction, because the H and Cl are actually trapped by the pyridine compound. Okay, uh, so just write a one liner here that pyridine is used to neutralize the HCl formed, okay, in the reaction. So next let's see another example wherein we have something like this. We have ETOH, and we are reacting this with anhydride. So what will happen in this case is, we'll get something like ETOH. The O from the ETOH will actually attack on this carbon atom, and as a result we'll be getting something like this as our product. Okay, so now what will we be getting next is, this acetyl group attached to the original ETOH. Obviously H replaced, this is called acetyl group. Okay, so let's look into what just happened in this reaction. First of all, esterification happened. Okay, second point is that acetylation of alcohol took place. This is our alcohol. Acetylation of alcohol took place. Third point would be obviously the molecular weight of alcohol. Here we had C2H5OH, and here we are having C2H5O COCH3. Okay, or in other terms I can write that the molecular uh, weight and or the molecular number of atoms increased by C2H2O. Okay, if you add C2H2O, you will get this compound. Okay, obviously in the as far as the number of atoms in reactants and product side is concerned. Okay, so molecular weight would increase by 42. Okay, so next it is a type of SN-AE reaction. So I hope you are able to visualize how the mechanism is taking place in the background. that this was the anhydride group we were having, and ETOH will be acting on this carbon atom, and as a result we'll be getting something like, first step in the reaction would be, we'll be getting O minus here, O attached, and OET also attached. Okay, obviously OCS3 attached. Next what will happen is, this O minus will actually create, or again create a double bond with itself in the carbon atom, and this group will be living as CH3 C double bond O negative. This is a stable anion you can get, and finally we'll be getting something like this. So in this, first addition and then elimination took place, and this is an example of SNA reaction. Okay, let's take another example. So now we have something like, if we say that A compound reacts with, let's say, X moles of Fe2O, and we get the molecular weight of A plus 126, so you have to determine the value of A, or rather X. So in acetylation of alcohol, molecular weight increases by 42, and if you multiply it with 3 you get 126. In short, this means that 3 moles of anhydride actually reacted on the alcohol, or you can put it like alcohol reacted with 3 moles of anhydride to form this compound, in which the molecular weight of the overall compound is 126, higher than the original weight. So you can say that X is 3. Okay, similarly, if you see this example, you get A compound on reacting with X moles of AC2O. We get A plus C10 H10 O5. Obviously, X is equals to 5. Why? Because if a single mole of alcohol reacted with a single mole of anhydride, it would form 1 mole of, or rather the molecular formula would have increased by C2H2O, and it would have formed the acetyl group. Okay, and in this case C10 H10O5 is there, so we'll multiply 2 with 5 to get 10. Okay, so X is 5. Let's see another example. In this example we have CHOH whole 4, and we have CH2OH. Okay, we react this with X moles of AC2O to get a compound like this. Okay, whole 4 and CH2OAC. Okay, so we have to determine the value of X in this. Obviously 5 moles of AC have been attached on this O, or rather this OH and this OH. Okay, so X would be obviously 5. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing some notes and then the mechanism of esterification. So till then, good luck and goodbye.